Today we're going to start the second unit of intermediate algebra, and we're going to start by taking a look at linear relations. So to start with, we're going to talk a little bit about graphing. So when we are graphing in our two-dimensional plane, our Cartesian coordinate system, as you well remember, I'm sure, you've got your x-axis as your horizontal axis, and your y-axis is your vertical axis. The x-axis is positive on the right, negative on the left, and the y-axis is positive above and negative below. And we're going to plot some points. Okay, so, one other thing about this. Ordered pairs are always listed with x first and then y second. If it helps, you can remember that's alphabetical. It's always x and then y. All right, so we are going to plot 4 points, A, B, C, and D. And if you have graph paper and a grid, that's great. The worksheets that it prints for you or whatever will put graph paper in there. So I didn't put it on here right now. But we're going to graph these particular points. We're going to graph them all in the same plane and just label them. So the first one is 5, negative 2. So the x value comes first, so we move 5 right first. Negative 2 means that we're going to go down 2, and we would be here. And we'd label it A. What would I do to do B? Negative 5, 3.
Go to the left, negative 5, and go up 3.
Okay, go left 5 and go up 3. Yep, about right there, and that's B. How about for C?
Go to the left 1 time and down 2.
Okay, and I've already got those marked, so left once, down 2 is going to be about right here. And then 6, 2 puts me 6 right, 2 up, around about there. Okay, so without my having a grid, I'm sort of eyeballing it, and you are in your paper as well. But with a grid, it'll be very clear. So what we're moving into in this section is we're moving into something called linear, specifically linear equations. Linear equations are those of the form y equal mx plus b, or y equal b, or x equal b, where m and b are constants. You've probably seen this equation before. What does the m represent? Do you remember? Slope. And how about the b? Okay.
It's x-intercept, or is it y-intercept?
It's y. You were close. Yeah, so it's the y-intercept. And more specifically, it's the y-coordinate of the y-intercept. So the y-intercept is actually 0 and then b, because the y-intercept is an ordered pair. But it's telling us that location. So what gives with this x equal b and y equal b equations? Well, those equations represent very specific types of lines. The first one is a general line. Any kind of a diagonal shaped, if you will, line would go with the first equation that we've already talked about. The line that I've marked that says y equal b, this line is a horizontal line. And the one that's x equals b is a vertical line. And we'll talk more about those later, but they are still lines. They're just in a different form than the first one. Now we're going to go through several different ways of graphing and different things like that. What we're going to do first is we're simply going to use a table to create values. So we have an equation given to us, y equal 5x minus 2. And we are given specific x values. They give us negative 2 to 2. And we're just figuring out if x is equal to that value, what is y? So there's not really a whole lot that we have to do for this except to substitute, evaluate, plug in, whatever verbiage you'd like to do for each value. So our equation is 5x minus 2, and the x values are listed over here. So the first one is 5 times negative 2 minus 2. So what is 5 times negative 2 minus 2? Negative 12. And we go down the list. So 5 times negative 1 minus 2. Actually, So we will not have to forever. Just for this example, do it with me, okay? There's also some features in some of the scientific calculators and the graphing calculators that allow you to put them all in at once. So yeah, so we're not going to do this forever, just for the moment. All right, so if we do 5 times negative 1 minus 2, what are we going to get?
-7.
Negative 7. The next one's 0. 5 times 0 minus 2.
-2.
Mm-hmm. About 5 times 1 minus 2? Probably going to be positive 3. And then 5 times 2 minus 2. 8. And if you notice, there is a relationship that's happening here. Each of these goes up 1 each time, right? And it continues down on the x values. Notice what's happening to your y values. What's the pattern over here? It's going up by 5. Why would it be going up by 5? Any guess?
You're changing the times and multiply 5.
Yep, the multiplication factor or the slope is 5. Yeah, that's what's happening. So it's going up by 5 because the slope is a 5. Now, that only works if these evenly go up by 1, right? Like if they were bouncing around or something, this wouldn't happen. But it does on this one. All right. So we're going to hit on a couple other things that are true for linear equations or lines. One of them is a distance formula. Okay, so distance formula looks really ugly, and it's really not that hard. But it says that we take the x values and we subtract them, and we square that. And then we take the y values, we subtract them, and they square them. And because we're squaring things, it doesn't even matter which order we subtract in, because the squaring eliminates the negatives. So it's kind of an interesting feature of this particular equation. And this actually relates back to the pictures that we drew very nicely as well. So for example, if I were to take these two points, and I'm trying to find the distance, right? What happens when I subtract the x values is I'm actually finding, let me change my line, this length, because this is one of the x values, and this is the other x value, right, along the horizontal line. And then, so this distance right here is x2 minus x1. And the y values, when I subtract them, are finding this distance right here, because this is y2, and this one would be y1. So this distance is y2 minus y1. And if I take this one and I square it, and if I take this one and I square it, it might look like something you've seen before called the Pythagorean Theorem. And that's exactly what it is. This would be an A, this would be a B, and this would be C. And we would say that A squared plus B squared equals C squared. It's just another version of the distance formula. Or you could say the distance formula is just another version of the Pythagorean theorem. They're the same thing. There's actually another equation that you see this happening in too, but I'll spoil the fun later when I show it to you instead of right now. So you can do this with these very rigid, like x1 minus x2 squared and so forth. Or you can think of it more as subtraction of the x values, and in the order doesn't matter. Either way, you'll get the same answer. I'm going to do it with the distance formula since we just wrote it down very rigidly, and then I'll show you what it looks like more in terms of this a general idea form, and you can use either one of them that you wish. So if we let this one be x1, and this one be, y1, and this one be x2, and this one be y2, and we're going to find the distance between A and B. So if we do that, we take the square root, and the formula says I take the second the second x value, which is the negative 2, and I subtract the first x value, which is a positive 2. So I'm subtracting a positive 2 and squaring it. And then I'm adding that to the y values that do the same thing. So the second y value is 1. The first y value is negative 3, so we have minus a negative 3. So I'll put the negative 3 in parentheses separately, and then squared. So this is very like formula based, right? Like I'm doing it exactly by the way the formula set it up.
I have a
So,
question.
yeah.
You're supposed to do x2 minus x1, right?
Mm-hmm.
On the last slide, wasn't it
Did they write it the other way?
backwards?
Yeah,
Okay.
they did. So we'll just switch them from the way I wrote it. Usually you see it written the other way, but it doesn't make any difference. So we'll just go with that. Thanks, Simon. I was trying to follow their pattern, that the way that the curriculum had set it up. All right. So what do we get when we take negative 2 minus 2? That's negative 4. So I have negative 4 squared. On the second one, I have 1 minus negative 3. So what happens when I have a minus negative?
Turns to positive.
Yeah. So this actually ends up being 4 positive, right? 1 plus 3, so it's a 4 positive. So plus 4 squared. So what's negative 4 squared? 16. And what's positive 4 squared?
16.
So we have 16 plus 16, which gives me 32. You're right. 32. It's 32. Yeah. And when I have my 32 here, we did this back in the first unit. We're going to break this down into its simplest form, which means anything that I can pull out of the radical, I will. So we can break this down into like 8 and 4. And 8 is 3 2s. And 4 is 2 2s. It's a square root, so I'm looking for pairs. There are 2 pairs, so 2 pairs come out. So a 2 times a 2 comes out, and a 2 is left underneath. Or more simply, it's 4 square root 2. If I think of this more conceptual, like from a graph, I can actually draw an xy ordered pair. Not ordered pair, an xy coordinate plane. And I could put these points on there. So we have 2, negative 3. And we have negative 2, 1. And we could think of it kind of like I did the triangle with the Pythagorean Theorem. So if I'm wanting to know the difference in the x values, we can count the space over here. So the distance from here to here, right? And I'm going to need the distance down here too. This distance would be 4. It's 2 on the right and 2 on the left, so a distance of 4 right here. This distance from negative 3 up to 1 would also be a distance of 4. And I can do 4 squared plus 4 squared equals, I'll call it c squared since the Pythagorean theorem uses c. And we could take the square root, and it would become the exact same thing that we got on this side, right? But it's from more of a visual perspective instead of from a formulaic perspective. So it doesn't matter to me which one you use. They are both the same. That's distance. Another feature when we're talking about line segments that we look at is we look at the midpoint, the halfway point. Feels like you've just got another formula, but you know how to do midpoint because you guys know how to do averages. If I asked you to take two things and I asked you to average them together, you could come up with this formula without me giving it to you. You would add whatever quantity it was together and divide by 2. And that's all that's happening here. If you're finding the midpoint, you're finding the average x value. So you add the 2 x values and divide by 2. And you're finding the average y value. So you add the 2 y values and you divide by 2. Okay? So it's the same thing you do with your grades, right? You add a bunch of grades together and you divide by the number of grades that you have. You find the averages for things that are weighted equally anyway. So, yeah, so let's move on to the example. I was trying to see if there's anything else I meant to say, but I think I'm good. Okay, so we have these 2 points, and we're going to find the midpoint. And the midpoint is averaging the values. So the 2 x values are here and here. So I add the 2 x values, so 2 plus negative 2, and I divide by 2. And then I add the 2 y values. It's negative 3 and 1, so negative 3 plus 1, and I divide by 2. So what happens when I add 2 plus negative 2?
0.
You get 0, and then divided by 0, 2 is still 0. How about negative 3 plus 1?
Negative 2.
Negative 2, and negative 2 divided by 2 is?
1. Negative 1.
Yeah, negative 1. So this would be our midpoint. And again, you could think about this graphically. I think this is harder to do graphically than the Pythagorean theorem with the triangle stuff I mentioned before. Like it's harder to just look at it and say, oh, it looks like it's going to be about right there. But you can at least get a really good sense of, are you getting a reasonable answer if you wanted to graph them? So if you graphed both of these, you could see, does it look like the number 0, negative 1 is halfway in between them? And it will, and that would be your midpoint. All right, a couple more things. Solution. We have talked about this before. A value is a solution if it makes an equation true. We talked about it when we had equations that just had one x value in it, and we were trying to see, does this particular x value solve it? And the way your problems showed up on your papers is it gave you a box, and it gave you like 4 different x values, and it said it was going to test all those 4 x values and see which ones worked in the equation. Sometimes it's none of them worked, sometimes one of them worked, sometimes all of them worked. You had different options. So when we're working with these, we're generally working with equations that have 2 variables in them. Now, the question that I'm doing the example for does not, but I think the next one does. So if you're given an equation, any equation, x, this one's x equal -5, all we're going to do is we're going to take the ordered pair and we're going to substitute it in. Now, because I only have an x value, I will only be substituting in the x values one at a time. So if I substitute in this x value, -4 equals -5, that's not true, so it's not a solution. If I substitute in the next one, -6 is equal to -5, that's also not true, so it's not a solution. And then the last one, of course, is -5 is equal to -5. That is true, so that one is a solution. So with one value, it doesn't look any different than what we have done before. It's not a very exciting example, but it does pop up, so I wanted you to be aware of it. The better example, the more general example, is number 9. So if we take a look at number 9, we have an equation that actually has an x and a y in it. So we have to put the x in for x and the y in for y. So in this one, I'll do it 3 times. So I'll do 1, 5 here. So I'm going to take the 2 times, and it says x, the x value is 1, plus the y value is 5. And I want to know, it's sort of like a question mark, does this equal 7? So if I take 2 times 1 plus 5, will it equal 7? Yes, it will. This works, so this one's a solution. Now, unlike when we were working with in linear equations that just had one variable, usually it was either like they're all solutions, they're no solutions, or there's one. Here you could have some solutions, like you could have 5 solutions and 2 that are not solutions. There can be a whole collection of different things happening. So we do have to really test each one of them. So our next one is 2, 2. So x is 2 plus the y value of 2. And again, we're checking to see whether or not this equals, in this case, 7. So is 2 times 2 plus 2 equal to 7? No, that one doesn't work, right? I have 6 on the left. So this one's not a solution. So this one's a no. And the last one, 3, 1. So I have 2 times 3 plus 1. And does that equal 7? Yep, that one works again. So on this one, I actually had 2 that are solutions and 1 that's not. Okay, so you just test each of them independently. At least, so Nolan, you were kind of asking me about this one before, like this weird table that I had at the beginning. Like, do I have to write all those down? And in this table view, not so much that I care right here, but if you're checking to see if it's a solution, I would like to see that because that's what's determining whether your answer is yes or no. It's a little bit different of a question than simply evaluating it for a specific point. Okay? All right, last example. On this one's an example where they just ask you to find a solution. Okay, so the fact that they ask you to find a solution means that we could have, because there's 26 people in this class now, 27 different solutions if you all came up with something different than I did. And all from different, there could be infinitely many different solutions. So as you take a look at this, you might think to yourself, well, maybe I want to pick something that's nice, or maybe I want to pick something that I always use x as a specific value. It's totally your choice. So on this one, it's not very nice to let x or y equal to 0. But if you wanted to, you could. So let's try one, and we'll do just a few examples so you can see how it will work. So you'd pick one number, like x equal to 1. And when you pick the x equal to 1, you're going to use the tools that we did back in Unit 1 to figure out what y would have to be. So if x is, I didn't mean 1, I meant 0, because that's what I said. X is 0. So if I let x equal to 0, I have this. So the first piece, this is 0. And then I have 2y equals 5. And then what would I do to find y? Divide by 2. And it's 2.5, or it's 5 halves, or it's 2 1/2. On this one, you can have lots of different ways to express your answer that are all equally good.
And then where did you substitute that in for y and then solve for x?
So you wouldn't, because if you did, it would just give you back 0. At this point, you're actually finished, if your question asked you to do this. You've got the x value because you picked it, and you can use whichever one of these y value versions of the y value you wish. I'm just going to use the 5 halves, and this would be a solution to the system, or to the equation. It's certainly not the only solution. Just like we picked x as 0, could we have picked y is equal to 0?
Yeah.
Well, yeah, we could. And we can pick x or y equal to whatever we'd like. So I'm going to pick one other one. So somebody give me something that's not 0 for x or y.
2.
2 for which one?
Y.
Y. Okay. So if we let y equal to 2, then we're going to be evaluating this. I have negative 3 times x, and then I have plus 2 times 2 equals 5. Okay, so x is the only thing that I don't know in the equation, which means I can solve for it. I have negative 3x plus, what's 2 times 2?
4.
4 equals 5. All right, systems of equations. We did this in units 11 and 12, or 10 and 11 rather, 10 and 11. What do we do to find out what x is next?
Subtract 4 to both sides.
Mm-hmm.
Leave the variable alone, and you divide by -3.
So I have negative 3x equals 1. Divide by negative 3. This one does not have a nice, neat other form. It just, negative 1/3 is what we get. That's it. But that's an ordered pair, negative 1/3. And then the y value, which we chose, was 2. And there are plenty of things we could have picked that would have given me whole number or integer values too. We just happened to pick something that got me some fractions. Okay? So infinitely many different options at this point. You just have to pick 1 or 2, however it tells you to pick. Any questions on that? Okay.